Alright, simplifying square roots or simplifying radicals. Here's the very basic essential understanding. Square roots and square exponents are opposite operations and cancel each other out. Let me explain. If I were to give you 3 squared, we know that what this is repeated multiplication, which is 3 times 3, which gives us 9. Alright, so we start here with 3, we apply the exponent 2, and we wind up with 9. Now let's go the other direction. So if I take the square root of 9, that's asking the question, what number do I use as a factor twice to get 9? And you give me the answer of 3. Alright, so basically they are opposite operations. When you square 3, you get 9. When you square root 9, you get 3. They kind of undo each other. So in effect, if I take, for instance, what is 9 anyway? Isn't that 3 squared? We just set it up here. So I could actually restate this as, this is the square root of 3 squared. Well, gee, the square and the square root cancel each other out, and you're left with just 3. The same can be said for variables. If I have x squared, that is the same as x times x, right? If I ask you for the square root of x squared, I'm asking, gee, what thing, what expression, what variable could I multiply by itself to get x squared? And you would tell me x. So the square root, so basically square rooting a square cancel. They cancel the effects of each other, and you're left simply with the object inside the radical sign. So let's use that now, and we're going to simplify some radicals. Now, what's one of the first things you need to, there are 2 things here that you need to keep in mind. First is the concept of perfect squares. Okay? Perfect squares are numbers that are a result of squaring. Perfect squares are numbers that are a result of squaring. So what we're looking at here, perfect squares are numbers that are a result of squaring whole numbers. So if I take 1 and I square it, I get 1. If I take 2 and I square it, I get 4. 3, I square it, I get 9. And so forth and so on. So perfect squares are perfect. They are perfect because when you take their square roots, the result is a whole number, which is a very desirable thing when you're simplifying radicals.